to Ithaca Web People for August. It's August. Excellent. Wow, that's going fast. Yeah, so this month we've got two presenters. We've got Seth Art who's going to talk us through some security for app dev teams. What's real versus what's hype. And then we have another talk from Greg, who is there, and I don't remember what the topic is. Socket.io, right, and user presence through Socket.io. So that's what we'll be doing this evening. As always, our space and pizza is hosted by Funkhouse. I really should pay more attention. By Funkhouse. Beer is brought to you by Envision, and I have two. What's that?
We're hiring.
And I'm hiring. We're always hiring. I have two T-shirts too to give away at some point, but I left them at my house. We get like 75% off our own T-shirts, which is either great or silly that we still have to pay for our own T-shirts. I can't decide which. But then they sent me twice as many as I ordered for the same price, so then that's like 90% off or something. I don't know. Anyhow, I've got T-shirts to give away. And then our meetup dues are sponsored by Singlebook, and I think that's about it. So yeah, hopefully everyone enjoys, and we're starting to think about already presenters for September and October. So check out the Trello board, check out the Slack channel. If you don't know how to get to any of those, find someone who does. Go to the website. I think there's hopefully plenty of ways to connect to us through meetup.com or whatever else. Yeah. All right. Without further ado, hand over to Seth.
All right. Thanks, Ben. All right. Hello, everybody. My name is Seth, and I'm going to be talking about security today. So I presented here about a year and a half ago about just general security 101. So I'll reuse some of the first slides there, but then I'll get into the new fun stuff. I don't know who suggested the talk topic, but I like it. It's a different take, security, hype versus what's real. So I am a professional penetration tester. For the first 4 years of my offensive security career, I tested web applications, some thick clients, but mostly web or application penetration testing. About 4 years ago, I switched over to more of a general consulting role, so I'm doing network penetration testing, vulnerability assessments, wireless penetration testing, phishing, so kind of the whole thing. So, but I've always had a passion for the app side, and I put together the Ithaca Sec meetup, which we meet at Brightworks, which is right by the State Theater. We meet the fourth Wednesday of every month. So if you're interested in security, you're welcome to that. So it is more of we all sit around one conference table and just kind of chat. The first hour, 45 minutes is general discussion, and then we kind of get into a particular topic. So before I get into what's hype and what's real, I wanted to talk a little bit about the language that we use. So a vulnerability, that is something that can be exploited. So that is an application coding flaw, or it is a configuration oversight, or anywhere in between. An exploit is the taking advantage of that vulnerability, and then the threat is the person or the person who is typing and exploiting, or the person who is executing, say, the script that is an exploit script. And then the risk is the potential result of a threat exploiting a vulnerability. So I figured I would just start right at the recommendations part. So like a lot of presentations, I had this at the end, but rather than bore you all and wait to get to the good stuff, I'm going to start with what should a small team do? That was kind of the proposal, and then I'll talk about some of the things that I consider hype, and actually that's a good segue. So when Ben asked if anybody from Ithaca Sec would be interested in talking about this, what we decided to do is talk about this in our last meeting. So this is kind of a collective list. We spent a good part of our meeting coming up with all the things you'll see, classifying them as hype, it's complicated, or it's real. So So here is what I think a small team should do. These are kind of basics. There's a lot on here. I didn't want to get rid of anything that we came up with on the list. So, in this slide or anywhere moving forward, if you have any questions, but I'm probably not going to cover everything that I have a bullet for. I'll probably pick, 1 or 2 per page. But if there's something that calls out to you, please let me know. Can you see that? So what should, as a high level, these are the things that we always see, that we see on every application penetration test or a network penetration test. So sanitize all user input. That is, cross-site scripting, SQL injection. We'll talk about that more, and feel free to ask any questions. But it's also, things that are, I guess, more prevalent now than they were 10 years ago when we started talking about SQL injection and cross-site scripting. Things like serialization and deserialization vulnerabilities, right? You might be sending a user serialized data, never even thinking that what if that user deserialized that data, modified it, serialized it back up, sent it to your application, and then that could cause some kind of code execution. Another one, for instance, is server-side request forgery, which we can talk about. Defense in depth, just because you're doing one thing that is not usually where you stop. When you're thinking like a penetration tester, what happens is we run across one thing, we defeat that, and if we're unfortunate, if we're unlucky as the penetration tester, there's some other control in place that is like a second catch-all. So that is definitely what you want to kind of think about and what you're doing that. I think I should start my timer here so I have an idea. Anyway, let me know time-wise, like every 10 minutes or something.
Sure.
So, multi-factor authentication, we talked about it on Slack a little bit. Definitely, multi-factor authentication is a must in 2018. Now, not for everything. Some apps still don't require authentication, right? You have to think about the risk and who the threats are. But in almost all cases, you should be considering multi-factor authentication for the apps that you create, but also for your infrastructure, right? So when you VPN into your network, or when you connect to your your Git server, right? That should all be multi-factor authentication, and ideally multiple levels. Account lockout policies, encrypt everything you can. So just because it's an internal, you VPN in, why not just have it over HTTP? It's just, again, that defense in depth, right? Every time you make it more difficult, it's more difficult for the hacker. Practice the principle of least privilege. This is, just general. We've been saying this for a long time. This has to do with your applications. So design your applications so that as few people have access to privileged information as possible. Also for your workflow, right? So your Git, your CI/CD, things like that. Double check your sysadmin stuff. So this is will come out through the kind of the recommendations on what we think is not hype. Just because you're not responsible for the server side, maybe you're just creating the application, doesn't mean it wouldn't be helpful if you kind of check and make sure the web server that's running your application, it's on HTTPS, right? Like, just make sure that it's not also available on HTTP. Make sure that redirect is happening, where if anybody does go to HTTP, it just gets redirected. Things like that. We see that all the time. And depending on what you're creating, that could be a little deal or that could be a big deal. Another one that we'll cover is S3 buckets, for instance, right? That might not be your responsibility configuring your Amazon cloud stuff, but that is real, and we'll talk about that. Okay, yes?
I don't know if you feel this is your wheelhouse, but you talk about this list of things that you need to secure. Maybe like an overview of like tiering things in terms of content that needs to be secured from your perspective. Sarbanes-Oxley, for putting out stuff in the world. PCI data, is this certain data to protect? Do a 1 minute overview of what you think needs to be secured from data.
Sure, yeah, it's really funny, right? So I spend my time a lot of my time learning how to hack things, right? What I don't spend my time on, and what a lot of other security consultants do, is like compliance and things like that. So I can only speak from the what would I attack on a penetration test, or what are the attackers attacking? And for that, it's all about passwords, right? So it's all about once I get access to one thing, that's usually the first thing I access is usually not what I ultimately want. So then I want to use that access, either use that network access and then get from your web server to the database server, or the web server and the DMZ to the internal network, right? So what I'm saying, right, so that's that defense in depth and kind of creating the levels of the internal levels of complexity. Shared passwords, right? So I log in, and this is one of the things I talk about as not hype. Don't store passwords in clear text. I mean, it's obvious, we all know that, but people do it all the time, right? There's a framework you're using where you just, what was it? It's just a struts application where I compromise the struts application, and in the Tomcat fold, in the Tomcat configuration, there's a plain text password that it was a service account on the domain, so things like that. So for us, penetration testers and hackers, it's all about passwords and network access control. Now, obviously, the ultimate goal is to get the stuff that would be, financial data, PHI, PII, things like that. Does that make sense?
Yeah, I think so.
Yeah. That's 10. Cool. All right, should get to it. Okay, so I'll go through some of these. So hype, SSL, TLS findings. By and large, most of them are hype, the scanner. So either your certificate has issues, or you're using a weak protocol, or weak cipher within that protocol. It's all good, right? You should definitely update that, and if you see the caveat, most of the time you have to. But that's not the way that hackers are getting into your application, with the notable exception of Heartbleed. Heartbleed, I don't know if you remember it, you were able to read server-side memory from the open SSL vulnerability.
So you're saying if you use SSL, it doesn't matter what
I'm saying that there is, even though I've been recommending don't use RC4 ciphers and don't use SSL v3 for a long time, there's no exploit that I can use SSL v3, that I can hack a server to use SSL v3. It's more best practice there, depending on your threats, right? Nation state, depending on your application, then it might be more important. Hype, so one size fits all for testing. There are a lot of different ways to test your application. Automated, manual, dynamic, which is, you're testing the live application. That's most of what I do in application penetration tests. Static, you're looking at the source code. They all are good at finding different things. So, and also one size fits all in terms of scope, right? So for a manual application pen test, some clients want a 2-day test, some want a 1-month test. It really depends on the risk of your application, the risk of the data, things like that. I will say that I've seen a lot of hype that, we scan all of our applications with automated scanners, every day, and that's great. That means that you're going to catch cross-site scripting and SQL injection every other day. But those automated scanners can't find access control issues or, session management issues. So that's the kind of thing that you have to do manual testing, and you can't do that continuously. So you have to kind of, decide the risk lines. Again, really quickly, the risk ratings from automated tools, those don't take into account the context of your application, your business. So, we do a lot of modification of risk in our manual testing. And then, of course, even an application penetration test does not guarantee you're secure. There's things that a particular tester could miss. It's important to know that. And they're all time boxed. Security by obscurity is hype. So you have your regular user, you have your admin users. If I just show the regular user pages and don't show them any of the admin pages, I don't have to, put access control into admin pages. That's obviously not going to work. We find that all the time. It's called forced browsing. So all I need to do is somebody tells me that admin page exists, or somebody sends me a link with a refer, or some kind of printout with a refer in there, and now I know that admin page exists.
You get things like, let's see, but
So there is like GUIs, right? Like that's good. So not all, that is. Yeah, there are some exceptions. That's good. That's a good point. And I'm not sure if anybody is run into RAS for real-time application security protection. So it's like a inline IPS that you put on your application server. Everything that I've heard is that it's all hype and it doesn't work and it causes performance issues.
Is that like the same thing as an application firewall?
It is not. I'll get to web application firewalls. So the web application firewall is inline. This is sitting on your application server, hooking into the application server.
This is like a Splunk extension, so it looks at all the log files and does it on all of those things. Install an agent, take your server down, maybe like 20% of the CPU, about $50 per server extra per month. Just to keep your
Okay, so now let's move over to It's Complicated. You didn't ask for this section, but we thought there was a bunch that we just couldn't classify, so it's a free. Bug bounty versus application penetration tests. Has anybody here have experience with bug bounty programs? Good? Bad? Average? So, what?
We run that.
Yeah, okay. So, and that's what I mean, like receiving messages. So, as I mentioned, right, if you do an application, if you have the money to spend on an application pen test, either by a standalone consultant or a consulting company, or you hire someone internally, you're limited by that tester's knowledge, right? There might be some things that I find really well. There might be some things that I'm just not that good at finding. I mean, that's the reality. With bug bounty, the idea is you have 1,000 eyes on it, right? And everybody's good at finding their own thing, and that is true. You will find more unique, one-off vulnerabilities because there's this one guy, he looks at this vulnerability on every single public bug bounty program. The problem is that I wouldn't say go just with that because then you don't have anybody who's spending 2 weeks at a time, 3 weeks at a time or more with your application, really understanding the business logic and all that. So it is complicated. If I had the money, I would absolutely do both, but nobody has that. Web application firewalls. So it's complicated because two levels. They are two different types. So there's the ones that, AWS has one in their cloud, but it's signature only. And so it'll catch script alert and it'll catch SQL injection. Then they have the Imperva, and there's some others that create ones that learn your application. So they'll learn every parameter in your application, and they're super powerful. So they can learn over the course of 2 weeks that the first name field on this page, only ever sees alpha characters, right, uppercase and lowercase. So if somebody tries to put, whatever, greater than or less than sign, it'll, if you enable blocking, it'll block that. The problem is you learn it, and then the next week, somebody has an apostrophe in their name or a hyphen in their name, and then now it's a usability issue. Question?
How responsible is to changes in the application itself? Like say you all see a lot.
Yeah, it's a huge mess. It causes organizations a lot of pain. I mean, you could do it if you work it into your pipeline, but then you have now more non-developers kind of involved in every single one. Yeah.
So, can I add something that particularly Amazon has? Microsoft's working on it. And you should ask for Amazon website we actually use. So they have a web that runs in the edge. It's not actually on the inside of your virtual network. And that web does not use rules. The rules are not exposed. The rules are actually, discovered by all customers. So when you find a problem and report that to Amazon, they add that to the rules, and so then all of a sudden everyone can do that. So they are just rolling this out, they roll it out and put it once, picking it Amazon company. That can really go out a lot of products. When your risk pops up, Netflix finds it, you're protected. And so with all the apps that actually have worked, this is what's supposed to be.
Okay, awesome. Thank
It does
you.
not help you with some problems. So just to but it really has helped a lot of apps to be
Awesome, and things are changing. So the other reason why WAFs have traditionally been complicated is because I find an injection vulnerability in your application, and it's too annoying to fix, and we'll just fix it at the WAF, right? Which is, which is great until the WAF goes down for maintenance, or 2 years later, the WAF is too expensive and you get rid of the WAF. And I've seen all sorts of things be fixed by the WAF, cross-site request forgery, complicated things. So I would not recommend that. But things are changing and moving to that edge, right? Akamai has and CloudFront was the other Akamai one, right? They both have WAF solutions that you can put at the edge there. Okay, certificate pinning. I'm not sure if anybody has used certificate pinning or creates mobile apps or the clients. So the idea with certificate pinning is that you ship your mobile app with your server certificate in the app. So that way if somebody tries to man the middle connection, the app will not working. Like, this is not my authorized Netflix, whatever, certificate. And that's great. It really works for a true man in the middle, somebody in the coffee shop trying to, ARP spoof. And it's important to know that it doesn't work for the malicious user trying to get into their own app. We still have to do our penetration tests on mobile apps. If I load that app in a jailbroken device, I can just basically make the OS tell the app, oh yes, certificate looks good, and I can man the middle of the connection too. So we find things like hard-coded API keys because they never thought that the user would be able to see that traffic. Threat modeling. Threat modeling is great. It's the idea at the lowest level of thinking like an attacker, right? Trying to profile who's going to attack you, and if they did, what would happen. Threat modeling is complicated because there are frameworks. It can be a huge ordeal, kind of like compliance, where it's like you spend your whole time threat modeling and you never actually fix anything. So I would say just think like an attacker, and don't, threat intelligence feeds, I'll just quickly, there's good intelligence feeds and there's snake oil intelligence feeds, things like, an IP is attacking Netflix, and if you have, can just block that IP at your perimeter, why not, right? That's great. Somebody creating a report telling you that somebody's attacking people in your sector, you just gotta ask yourself, what would I do with that information? All right, so I wasn't sure if anybody would get the real world reference, so I found an image that had it in there. So I've split up these are all not hype. So application security is the basics. This is the stuff that's in the OWASP Top 10. If you're not familiar with the OWASP Open Web Application Security Project, tons of amazing documentation on what all of these vulnerabilities are and how to fix them in these cases. So injection vulnerabilities are not hype. They are the real deal. We find SQL injection, code injection, cross-site scripting still all the time. If at the end we can talk about any of these in more detail, just to give it for time. What is my time right now?
We are about 20.
Cool. So what's also not hype is using the framework-based sanitization tools. That's been a big improvement in the last, decade, 5 years. It used to be that everybody had to roll their own input sanitization and output encoding frameworks, and then OWASP tried to do it, and it was okay, and it just supported Java. But now, Ruby on Rails, right, Node, or all the JavaScript frameworks, they all kind of give you this for free. So you can still get yourself in trouble if you try really hard, but definitely use frameworks that have that built in. I don't know if anybody wants to add to that. So other application security issues that are the real deal, we still find insecure direct object references. So this is the most simple case is, I get my boarding pass. This is a true thing that actually happened to one of the big airlines. I get my boarding pass. I see on the URL, it's like, ID 1234. I put in ID 1235, and I get, the next guy's boarding pass. Like that, we still find that all the time. So think about your applications, think about if that is going on for you. Server-side request forgery, well, again, I don't want to get caught up too much in these, we can go back. But server-side request forgery is especially important these days with everything in the cloud, because all the clouds have different metadata services. right? AWS has it at what, 169.254, 169.254. So if I can make your server make a request, then I can potentially request that metadata service and get potentially sensitive information about your cloud environment. For instance, you might have a startup script that has hard-coded credentials in that metadata service. That does happen. You're not supposed to do that. Insecure storage of sensitive information. So we kind of covered this, right? Passwords in config files, passwords in the database, passwords hard-coded in your mobile applications or other thin clients. That's stuff that we find and so for bad guys. So you probably noticed, right, it's hard to talk about what's not hype because I switch between talking about it from the attacker, so exploiting SQL injection, or talking about it from what you should do, like, sanitize input, so this is one where, I'm talking about it from, you should do, it is not hype to enforce multi-factor authentication, as mentioned. Brute force protection, account lockout policies. One size does not fit all, but this is really important. This is not hype. This will really save if they can, it might be a soft lockout policy, right? It locks out after 3 invalid, just for a minute, or 5 invalid, but we all see that on the iPhone. I don't know if you've seen those pictures where eventually like a kid tries it 1,000 times and it's like, 4 years or from Okay, vulnerabilities inherited by third-party components. So this is, you're using Ruby gems that are vulnerable. You're using, node modules, Python modules that are vulnerable. They can very much make your application vulnerable even though you didn't write that. So keep an eye on that. It's not easy, but it is real. You find vulnerabilities. I just found one this week actually. So they're using just a really old Python module to do their websites. That is vulnerable to a directory's first vulnerability. So don't push your Git repo to your public servers, or I guess if you do, have a way to HT access that away, so we can get to it. A bunch of us at Ithaca all share stories that whenever that happens, there's tools that will take that, .git folder and basically recreate the whole thing for you, and we found hardcode credentials in there, configuration files, source code, which can lead to other things. Don't publish private key material to Git, and if you do, I don't know exactly how to do this, but if you just delete it, it'll still be in history. So there's like extra steps that you have to do.
We actually just had a mission last week where someone posted our Amazon secret key and access key to Git at like Monday morning. They decided that we discovered it until 9:30 in the morning, and someone was like scanning the pages they got our AWS key. They deleted all of our servers and we got 300 servers across the entire data center and cost us $7,500.
Just this week.
Just this week.
Yeah.
So yeah, don't publish your keys to
Can I add to it? Also, don't publish default passwords. Like, that manage 200 security breaches. And it's always because the DevOps team automated and installed some component, and they use the default passwords. And 90% of the breaches that have to kind of either publish keys or some, change the passwords. So we use a little like test. You have to run on a test to check the default password. Also, to add to this, don't public keys. You will get breached. Assuming you will get breached, have a process in place in order to change it. Most big companies at this point rotate their keys every few months, all keys. If they're only going to put some compliance like ISO 500 stuff, they have to be able to do it.
Yeah, no, that's great actually. More than just that, just in general, right? Prepare for what's one day will happen. That's awesome. And default passwords, right there. So moving over to, it's not always clear application versus infrastructure, but I tried to kind of classify all these. So these are the things that might not be your direct responsibility, but it's a team effort to keep something, working and team effort to keep it secure. So kind of covered a bunch of these, but definitely, so not default passwords just of your applications, right? Default passwords of, your RabbitMQ server administration console, all your administration consoles, right? It's even though you might not be responsible for that, check it. Go Google default password, and help your team out unprotected. There's 3 buckets. Apps running with unnecessary execution privileges. So this is running as root, running as a system. So this is definitely a real big deal. We still find this all the time. Yes.
I would say also for your database, because a lot of times when you're setting up Postgres, it's easy to just like let your Postgres user do everything. But if some companies use your app server, they can do everything with Postgres without Postgres.
Yes, actually, right, exactly.
Database, whatever.
Yeah, no, that's a clear example of the least privilege, right? Separate out as much as you can, because that's what we do. Yay, I got a new Postgres server. Well, I might be able to do not that much, or I might be able to do, a lot. So vulnerability is inherited by your tech stack. So not just the stuff that you have chosen to include, but the stuff that you're running on. And don't trust that vulnerability scanners will find all that. So Struts is a good example. The reason Equifax got breached the way they did, they were running vulnerability scans. But we've run into this too. We found Struts right after running our own vulnerability scanners. They didn't pick it up because the Struts application was, in a subdirectory of a subdirectory. And unless you browse to that, then you don't see that .action file and then get ticked off with Struts.
Would you consider regular dependency updates to be mitigation for inherent vulnerabilities?
Yeah, dependency updates, and also that's one of those where the threat intel feeds are complicated. You can pay companies, you give them a list of what you're using, and they will let you know if there's vulnerabilities in that software, and I think that's cool.
I've seen on GitHub recently that if you have a package.json file in Node pack, it will actually tell you at the top of the GitHub repo that you're using older vulnerable packages and this ones.
I was just in the GitHub settings and I saw something where it's like, do you want us to email you if we find something in the dependency? Yes.
It's called dependency graph.
Yeah, that's awesome.
So with digest, you get all the time. It tells you what's going on.
Yeah. So right, exactly. Utilize that stuff. We all don't have to reinvent the wheel.
So don't suffer by with, but back to the real world. If you look at really old applications, similar to the dependencies are all the way outdated. I've never seen a breach because of that, because the main reason is for most of the problems, they have to actually get onto the server for them to reach into the code. And so think about what actually you have to penetrate to use for security. In most cases, you don't get to it because it's stuck at the firewall. But if you get beyond the firewall, then you have more problems than everyone. That is a security issue. So most bigger companies with code bases can't really afford to update everything. You can do it, but you can't.
If updates are expensive, you have to think about the trade-off. If updates are cheap and easy, then you should just do it and not bother thinking about what it will take to exploit.
Yeah, the other thing that's connected to that is you keep the account separate. So one of the things that is underused and one of the most secure things to do make things better is keep developers and QA in a separate account or in a separate private virtual private network than your customer data. Because it is so hard to develop and do all the work as a developer and not sometimes tweak the rules a little bit and then you forget and over the system. But having an exposed development account, you get some bitcoins from harvesting, but you know what that is. That's another thing.
Okay, so I think we talked about this one, lack of encryption. So not just in your app, but all of the things that you're using in your pipeline. Same thing, multi-factor authentication, not just in your app, but consider. So in Slack, somebody asked about the stuff that's in the news now with Reddit, right? They're using SMS-based multi-factor authentication, and they think that that's how they got compromised. I'm not sure if anybody heard about that. And they're basically saying use hardware tokens or something like that. Yeah, I think SMS-based multi-factor authentication is better than nothing. So you should do it. But I use a YubiKey I really like it. I use a YubiKey to personally to unlock my password safe and my KeyPass. That's how I use it. I don't use the YubiKey kind of like go off the YubiKey protocol, the service. And then, to get into our AWS environment, we use an open VPN server that has Duo, which the Duo app is amazing. I'm sure most of you use it. Microsoft Authenticator has the same thing for Office 365. It's great. MFA on everything. Yes.
Is there a way to do MFA on SSH, like SSH into a server? Because we use keys, but I don't know if to do like key plus something.
Yeah, Duo has a script that you can install. So yes, I know it's possible.
There's another solution for it. It's cheaper, and that is something that temporary password services like that have been doing for libraries. They basically, request for the department, for example, that they get 20 temporary passwords that are available for half an hour, and then the scripts can have all the passwords to access everyone for a long time. The passwords for the and you just know the passwords for the easier to support than if you're using
Yeah, exactly. MFA, right, beware of the pitfalls of MFA, right? So Qualys is the vulnerability scanner that we used for a long time. We enabled MFA, they use like a semantic VIP app. To get into the Qualys interface, you have to use your multi-factor phone token to get into the API. No MFA, same data. Like, what's the point, right? Why even go through the, all right, how am I on time?
You were at 10 minutes later than last time.
Perfect. Okay, so I think this is the end. It's not just you, it's not just your infrastructure at the organizational level. Create a security account, for your organization. That is the way a security researcher will contact you if they notice something. I can't tell you how many times, well, not that many times, but a lot of times I found something and I basically have to stalk the security team on LinkedIn to find the right person to reach out to. It's pretty funny. And so, pen testing, what I do is just one thing that in bug bounty programs, they find their own vulnerabilities, but there are things that security control assessments find that we can't find, right? Are you logging authorized actions, right? Things like that. That's really important. It's not something a hacker is going to find, but that's going to save your bacon potentially if you're logging all privileged access or and alerting, putting that to Splunk and creating events. And that's it. And
I actually have a question for you. So one thing I've been thinking about since we have that conference that I told you about the RSP credentials is I definitely heard of services where you can actually store your credentials in the cloud, and then there's some sort of like mechanism to connect and download your credentials. Do you have any experience with those servers, the services rather, or what kind of solutions do you have for storing credentials, either on your server or somewhere where they can access them?
okay, so this server, your infrastructure.
Yeah, so like Amazon keys, like Walmart keys of third-party services, whatever you're using.
So there are a couple of big software companies that do that. Something with Vault in the name. What? Vault. Okay, yeah,
All
right.
self-providers have key storage. All of them do use one system. And it's the most secure because all of the cloud provider actually monitors what they want to do. So the lazy use what the cloud provider actually focus much more configurable than the lazy. That's why we use it.
If you're in AWS, EC2 parameter store, just put everything in your parameter store, and you can do it a few different ways in there, but that's how we do all our server-side stuff. It's in EC2, and it's in there, and I guess they could get it. It's parameter store within EC2 and Docker.
Are you talking about for people to access or for your I'm saying for the application itself. So like, we have everything within Docker, we gets read and gets written to process stuff, right? We create instead of just building on the service.
You can lay that down, as part of your build. If you're in Docker, you can lay all stuff down as part of your build pipeline from EC2 or CS. It's just part of the build.
Is there any DNS best practices in
Any what?
DNS?
DNS. How do you mean?
Just in terms of like configuration, like just something that you say you should
Don't allow zone transfers to anybody. Whitelist zone transfers. That's usually default. You have to on purpose mess that up. No, I mean people talked a lot about DNSSEC. I don't know if you're familiar. There was a whole thing, and a lot of the research community was like, "No, that's not going to work." That's the security community. So I think the end result was no to DNSSEC.
And more of the web is actually supported today. So when you do software on the website, for example, Amazon does not support DNS. So even if you send it out, it doesn't.
One thing we're working through in a lot of our services right now is just failing to validate input. Like input in the way of URL parameters, like actually the URL itself. That's something I don't know why I never like. I was like, oh yeah, I love all my forms. That's fantastic. But like when you think about, oh, you're passing in like an ID in your URL, and you can pass in anything in there, and your code starts running something like that. So I don't know, it's just an interesting way to see our internal security team, how much they were able to screw out stuff to people who weren't following the URL, what the actual URL structure should be. So another thing interesting to remember.
Cool. Yeah. So right. So just the logic was getting the query parameters, but not. It just wasn't acting on
It
them.
was like we've got like a URL is like, object slash
Yeah.
GUID, right?
Yeah.
And the GUID can just be like half of things.
Yeah.
And like there was no validation, so that and then the code would just take that GUID and turn around and ask an internal service like, hey, give me information about this GUID. And you can just pass it in. And like path reversal stuff, like reading slash in a URL, like things that I was unaware of that you could do.
Yeah.
Terrible, terrible things.
Yep.
So, yeah. Be aware of all of this.
Can you talk more about encryption?
Encryption?
Middle levels, encryption everywhere. So let's.
Yeah, absolutely. So there's two types, right? I don't know if everybody, but there's encryption in transit and encryption at rest, right? So most of what I'm talking about, so thanks for the question, because most of what I'm talking about is encryption in transit.
Okay.
But what?
I'm more worried about it.
Yeah. So at rest, you think about it like this. Think about so there's sometimes where hashing is better than encryption, right? If you never need that data back again, you just want to validate against it. So if that is the case, do that. Encryption at rest, otherwise you just think, so if the attacker compromising my server is the key on the same server, right? And it probably has to be, but you try to think about ways to abstract that, and somebody here probably can talk about that more than I can.
So if you look at the history of encryption, it's actually mostly asked for because almost all states now have a law that the data has to be encrypted. So when encryption address came about way back, then people actually ran into the data center, store the disk, and ran it for hundreds. And then all of a sudden you have the disk in your hand and you can read the data. That makes sense. That is bad. But if you actually, in the cloud, if you run into a data center, Amazon data center, and steal the disk, it's this data. So encryption does makes a lot more sense. I have not, worked with a large team and asked the question, we want to figure out a way to actually give us an encryption address that is secure if someone reaches any one of the apps. So say, for example, use S3 encryption address. If your app server is running, that key to unencrypt S3 has to be on that app server, so you have to find it. Uses, right? Encryption address was invented for stealing money. It does not actually work in the world. Now, if you do business in New York, know that by now you're required to actually encrypt all of your records. So, for regulatory reasons, it's very important. For security reasons, I have never heard of anyone using it in the wrong language.
Well, so one example that and you guys can probably explain this better than I can, right? But back 5 years ago, you compromise an ASP, a .NET server, and you get the web.config and you get the plaintext password, right? Now there's ways to encrypt that password. How is that? Where's the key for that? When you encrypt that password, then
Those keys are stored in keys. But again, the program is running, right? It's logic key. If you have it in memory, that memory has to contain the key to unencrypt. So if you actually reach the server, you will get access to the key. The most secure thing to actually prevent
the
that.
physical server.
The physical server.
Yeah, but what if I have access?
The virtual machine. You get access to the virtual machine. You have access to all the keys.
Yeah. But what I mean is, like, say I have access via command injection or SQL injection, then that encrypted password in the config file, as long as I can't access the key, is valid, is important. But you're right.
That's the most secure thing for actually reaching the, another thing from the real world. Most big companies kill all servers with the units. So if you have a server running, right, and someone attacks and breaches the server goes away in 30 minutes, they can't do a lot of that. So, using that auto scaling not just to scale, but to rotate your servers and don't have any of the servers running is one of the most secure things to do because you don't have a target anymore. That IP address goes away. It's not as an server, IP address goes away. And so if you do that, that's usually the best protection.
You just said most companies in 30 minutes take their servers down.
Also, because usually big.
No way, man. Like I work
Well,
for
okay, sorry. It's the real SaaS companies.
I work for I work for Fortune 500 companies, and people don't even notice it months after often. Most big companies are not that simple. I expect for that.
Okay, so I've worked with companies where we've done it, and I've heard.
IBM and Tiffany, nobody, they don't know. Like, you don't know. Like, it's just not. That's great. That's visual thinking. Man.
Kind of encryption algorithm is really important. So you know, parameters, graphical parameters.
Yeah. Yeah. Good point. Yes.
I heard that Google has a service that will handle user and access management for you. Security system.
How do you? Yeah. You love it.
So, I mean, I don't trust Google, but they know security better than I do. And probably better not to have stuff on my own server. Would it be better to have them in the home?
I think generally that's how I feel too. It's better to have the big guys do it rather than do it yourself. Steve, are you gonna be a question?
Yeah, so I've been writing these down as we've been going, and there's 25 of them, which is still, in my mind, a lot for a small team to do. Obviously, there's the OAuth top 10, but do you have like the set top 3?
Yeah, that's what that first slide was. Right here. I mean, I guess that's why.
You know, but the top 3 become top 20 once you the first page.
Yeah.
Top 6 once you the second page.
Yeah.
So,
Right. It was really hard to like. Right. That's what I was going to make that joke about this talk. Right. Like security, hype versus real. So that's basically everything in security. I could give you for days. Yeah.
So on the point of, having keys in memory, so what's the point of having encryption at rest? Like, is there any, kind of, industry business how actually easy it is to do that? I mean, let's say that you do that to the server, but then you're kind of faced with, opening dev payment and, searching through all the memory, right? And then when you're looking for out, is there, any, in the security industry, kind of good anecdotes or stories about that?
So, I don't know the person that's the security teams I work with. And you take the S3 function to open the S3 up. It takes that key. So if you start monitoring on the server with other calls for that call, that key is found. I know that server, I can easily write a script. Create the cloud, and I would like that. Now, again, I've never heard of it. We talked a lot about I've never heard of using these kind of things to actually access it. I don't know. I consider encryption as high personally, But for databases, database was always like whenever we pay for a service, we have to do this consider the database data independently. Yeah, service that never been only using, but then never accessible to
All right, well, thank you to Seth for that. Take a quick 5 minutes, and at 6:30 we'll start with Greg.
If they must know of the Node, AWS, Jenkins, Docker world, I can tell you about that.
We're live. We're live. All right. Awesome. So, for our second presenter this evening, we have Greg talking about real-time user presence with Socket.io. Take it away.
Hello, everybody. Thank you for staying. I am Greg Kops, and I'll be doing a presentation on real-time user presence with Socket.io. So, quick show of hands, who here knows what a WebSocket is? All right. Who here has actually worked on an application with WebSockets? Good. Who here has worked with Socket.io? Right. Cool. So, there are some people at least who I can go basics to, and they won't be bored. All right, my name is Greg Kops. I'm the CEO of Untitled Chapter. I've been doing web development since 1998. Currently, I work for the Cornell Cooperative Extension. My company is Think Topography, and I am the lead developer on an open source project called the Maha Platform, which we built at the Cooperative Extension. Oops. All right, so WebSockets. What are WebSockets? Well, at the most basic, WebSockets are a network protocol for sending and receiving data over a network. Kind of a dry way of thinking of them, but like think of HTTP, like the way you send like an XML HTTP request. The WebSockets are an alternative to sending something over standard HTTP. WebSockets are currently supported by all major browsers and by most modern programming language, at least the programming languages used in web development. And sockets can be used in web development, in native app development, and you can even use that in server development to have server systems talk to each other. And as I said before, WebSockets are an alternative to the HTML, HTTP request. So what's the difference? So I put this diagram together here to show XML, HTTP request. Which is what most people are familiar with loading a page or doing an AJAX response. You have your client, it sends a request to the server does some process and sends back a response. Every time you want data, you're going to make a request, you're going to get a response. You're going to make a request, you're going to get a response. And that works fine. I mean, most of our web apps that we built, to date, work that way. But it's not quite as fast because if you think about it, there's a lot of setup that needs to happen before a request is sent, a lot of teardown that has to happen after it's done, and then it has to happen again on the server side. So there's a lot of overhead in just sending information back and forth. So how does a WebSocket make this better? Well, a WebSocket, it opens up a connection to the server, and then that connection stays open for as long as you need it to stay open, until the client says, all right, I want to disconnect. So the setup is done here, the teardown is sent here, and then throughout the life cycle of the WebSocket, you can send really tiny messages back and forth. So it's ideal for if you need to send an update about a message that has come, or a notification that needs to be sent. And you, instead of having to pull the server and ask every second, every 5 seconds, every minute, you basically can say, hey, let me know when there's a notification, and when the server has one, you can just send it over that connection. So the connection stays open. There is a little, Socket.io has a little system built into it where it sends heartbeats back and forth, so it just checks to see if the connection is still open. It is full duplex, which means that the client can send a message to the server can send a message to the client. It goes both directions. And ultimately, most importantly, is there's no response required. So you can just send the information and move on. You don't have to be waiting to figure out if it actually made it or not. And in some situations you might want to, but in most situations you send your notification and you're done. Any questions about that? Great. So, what is Socket.io? Socket.io is a JavaScript library for WebSockets. And there's an implementation for both client and for server. They're available as NPM packages, so you can get Socket.io or Socket.io client. The default for Socket.io is that it stores everything in memory. However, if you want more persistence or you want something a little more robust, you can use your file system, you can use Redis. There are a number of backends that you can use that are kind of interchangeable. One of the things that Socket.io does that made it really popular is back when we were still waiting for full adoption of WebSockets, it had a kind of fallback polyfill. So it would do what I was showing earlier with this long-term polling, where it would request and get a response, nothing yet. It would ask again, nothing yet. It would ask, all right, here's your message. So it did have a way of doing long polling if you didn't have WebSockets on your browser. So Socket.io also does something called rooms or namespaces, and this is really kind of like a pub/sub model. So if I say, I'm really interested for this moment to subscribe to all chat messages that come in through this channel, now whenever there's a message on that channel, I'll get that specific information because I subscribe to it. And so using what they call rooms or namespaces, you can basically subscribe to some, but not all of the messages that are generated on the server. And of course, it's smart in your application about how you give people access to different rooms. Most importantly, you don't have to open up a different connection every time you're in a different room. It really multiplexes all of those communications over one socket. So really your application, no matter how many different things you're doing with Socket.io, you open up one connection, you leave it open for as long as you need to, and then you close it, and you can do all of your socket work with one socket. And everything in Socket.io is implemented using the listener pattern, using threads. I will get into more detail about that in a moment. All right. So, if you have never set up Socket.io before, let me tell you a little bit about how it works from a network perspective. So, you have your Socket.io server. Socket.io is a JavaScript technology, so you can run it using Node. So, let's say you have one Socket.io server. And if that's the case, you don't need any of this other stuff. You can directly connect through the internet to your Socket.io server if you choose. However, in most situations, you're probably going to at some point need to scale it. So if you choose to set up your architecture so it can scale, you can have many Socket.io servers and they share some sort of backend, whether that's some sort of shared memory, shared file system. I use Redis in the application that I work on, but the idea is you have to have some place where you're storing subscriptions, some place where you're passing messages back and forth. So if something gets sent to one socket server, but then has to go to a client that's subscribed to the other socket server, there's uniformity across your whole socket layer. So you have a shared backend, but you always have a load balancer that kind of has like a single point, a single endpoint. Because your TCP connection is going to be open for the duration of your socket, you really are going to have to use what they call sticky sessions. So if we use HA proxy or Amazon's ELB, they have a mechanism where they'll like set a cookie, and that cookie will be sent every time that that connection happens, and the cookie identifies, oh, we're using socket server 1 versus socket server 27, and so all of your messaging is always going through the same server, and that there's a lot of stuff in terms of just managing the connection that goes away, which of course you don't have if you're not load balanced, but you do need sticky sessions. And so the client connects to the load balancer, distributes the connection to the Socket.io server, and the Socket.io server uses its shared backend to figure out what it's going to send back or what it's going to do with the message that it receives. So that is network architecture for Socket.io and for WebSockets. Any questions about that? Awesome. All right, so what does the code look like? So Socket.io on the server, I'm going to show you on the server first, then we'll look in the browser. But on the server, Socket.io integrates with either Express, if you're using Express, or it can integrate with just Node's out-of-the-box HTTP server. So you can see up here, I am using Node's HTTP server, and I've imported Socket.io, which is the server-side framework. I create an HTTP server, which I'm going to call Socket, and then I create a socket.io object passing that socket that I'm going to connect through. And now I have an object called IO that I can work with. And that's what I'm going to work with for the rest of my, time here. So it works, as I said, with a listener pattern. So events. On, you're listening for an event that happened. Emit, you're sending out an event over the connection. So the first thing that you see here is this. When we get a connection, we're going to initialize that connection with this con variable, and throughout this whole body here, con is now going to refer to the active WebSocket that we have with the browser client somewhere over here. So IO, I said here, IO handles all the connections, and con handles the individual connections. So if I say IO emit, and I say someone arrived because they disconnected, everyone who's logged on right now, and whether you're on your mobile device or on a laptop or on a server, you're going to get this message, someone arrived. But now I'm going to actually send a message directly over the connection, so this is only going to go to the person who's connected, and say, hello, new guy. And as I said here, you can use optional callbacks. So you can say, just send the message and do nothing. However, in some scenarios, you actually don't want to know when it got there effectively. So the callback will actually do send it there, and when it gets delivered, pass a message back and execute the callback. So that would give you somewhat of a kind of HTTP kind of traditional kind of model if you use this callback. So it's going to say, hello, new guy, it's delivered, going to get the callback. We also can now say, I don't know, at some point I might get a ping message over this connection. If I do, here's how I want to handle it. So you're going to set up all of your handlers for all the different messages that you and your application choose to implement. So when I get a ping, which will happen at some point, I'm going to then write back to them all. Kind of boring, but basically it's showing how you set up these handlers, and they just run for the duration of the socket. They're always there waiting. Lastly, we have something called disconnect. And disconnect happens when the browser crashes, when somebody leaves and browses away from the application, or when a browser tab is closed. So disconnect is a way that somehow with socket.io, when the heartbeat fails, it knows it's no longer connected and it issues the disconnect. And so when the disconnect happens, I'm going to tell everyone someone left, and then say goodbye, new guy. But actually, now that I think about it, that would never get there because we just disconnected. But this is just example of it. And then, of course, just like you do in any HTTP server, Express server, you say what port you're going to listen on. So that is, in a nutshell, how socket.io works with the server. Now, of course, no security here, no shared backend. I'm not using Redis. Clearly, you probably want to pass a JSON web token or a cookie along with it, and then take that and authenticate the user. Maybe when you're subscribing to channels, you want to check, should this person be subscribing to this channel? That's all application logic, but you certainly can implement anything you want right here that will either approve or deny the connection based on some security or access control. Any questions about socket.io on the server? Sandra?
So, in the how do you kind of callback that will be on the server side when successfully receive that?
Correct. When the message is delivered, it sends some sort of a notification back to the server, which is true. Yes, and I'll show you that when I open the browser. There's like some weird thing where like it goes into kind of like freak out mode and is trying to figure out what the hell's going on and starts sending packets back and forth, or it starts trying to make an HTTP connection because it worries that maybe it's like lost the socket. So socket.io has a lot of kind of self-healing built into it, which is, I'd say 99% of the time perfectly exactly what I need, and there's only sometimes where I'm like, I don't want it to do that, I'm going to figure out some other strategy. Any other questions about socket? Awesome. Socket on the client. How many people here are React or no React? Know what they're looking at? All right, so this is a React component. You really don't need to know, I guess, too much about React other than render. It's going to make it look like something. Use your imagination for what this code looks like. Componented mount is a lifecycle method that's called as soon as the component starts. So here's where I'm putting my socket.io. But if you're a Vue programmer, or you're an Angular programmer, or you use jQuery and just raw JavaScript, you can just do this right in a script tab. I'm just doing it with a React component because I'm a React developer. That's just So I'm going to now import socket client from socket.io client, which is another NPM module, but it's the client side of socket.io. I'm going to initialize the client and point it towards my server, which this one is running on port 3000 at localhost. And now I have an instance variable called client. And just like I did on the server side, I'm going to set up listeners. And so I'm saying when this client connects, I'm going to call the handle connect method. When this client gets a POM, I'm going to handle the POM method, right? So handle connect, when connect comes from the server, I'm going to send a ping back, and I can even ask for a callback, much in the same way that they did on the server. So if I emit something on the client side and I want to know that it got from the server, I can ask for a callback as well. So I can be certain that it made it back to where I sent it to. So these callbacks can be used for asynchronous logic, but they can also just be used to just double check to make sure what you wanted to happen actually happened. Yeah, so I mean, that's really it, listener, emitter, on and emit. That's like 90% of what we'll do with socket.io. Any questions about socket.io on the client? Great. Let's build an app. So I have this, the source code for the app I'm going to build up at github.com/Mochini/socket.io presence. If you'd like to follow along, and if you're really ambitious and have your map pop open, which doesn't say many of you do, you can actually install it if you want, but I'll show it to you. All right, so one of the subjects that I actually find really interesting that I saw.
Do you want to go back there for a second?
Yeah. Sorry. There you go. And just so you know, I mistakenly sent this entire slide deck to the listserv because I thought I was sending it to I thought I was sending it to Charles, and his name auto-completed to the web meetup listserv. So you'll have this slide deck whenever you want it. Right, cool. So one of the problems that I actually used socket.io to solve that I was really happy with the result was user presence. So I manage an open source project, and one of the things we have is real-time chat, but we also have all sorts of commenting features, and we want to know who's online when they're looking at something. When there's a fire.
It's going to be sitting in traffic for like 5
I'm waiting for the call.
Sorry.
Okay, got it. So you want to know who's online, but there's more subtle things sometimes you want to know, like, are they actually on the app? Like, if it's a mobile app, are they actually looking at it right now, or are they elsewhere? Who uses WhatsApp? Or has used WhatsApp? I love their presence feature because they'll tell you when someone's typing, they'll tell you immediately when they've left, they'll tell you immediately when they come back. It's like super good at telling you in real time if the person's actually paying attention and there to receive the message that you're sending. So the app that I'm going to show you today is built to give real-time user presence using socket.io to let you know as soon as someone's looking, as soon as they read, when they sign in, when they sign off. And ultimately, we want it to look something like this, where you log in, you sign in, you show up. If this is your tab, you have your circle green. If other people are logged on but they're not looking, you have an orange circle to let them know that they're logged in but they're not looking right now. So the requirements of the app are it has to have the ability to manually sign in and sign out. We want to track which users have the tab focused. We want to be smart about handling crashes or when someone closes a tab, and we want to be able to deal with a bad network connection. So what does the data structure for this app look like? Well, it's really simple, and it's the same on the client and the server. We're going to have an array of users, and the user object has the name of the user and their status, if they're active or if they're absent. Active is going to be rendered as a green circle, absent will be rendered as a yellow circle. You would definitely want more information in your app, like a user ID, because if there's 2 Gregs, my application sucks. But it's just easier. But you have larger user objects for the demonstration purposes. This is what we got. Questions? Sorry about the app or the data structure. Okay. All right. So my app is going to basically deal with 5 events, and the first is going to be connect. And it's going to happen as soon as the person opens the app in the web browser. So the client is going to connect to the server, and the server is going to emit something called presence back to the client. We're going to say, I know you're not logged in yet, but here are the 6 users who happen to be logged in right now. So I'm going to get that initial user object and I'm going to store it in the client. Now I'm going to have another action called sign in, and I'm going to send my name and I'm going to send my status. You might think it's not important to send your status, but I'll show you why in a second why that is important. So I'm going to sign in and I'm going to send status of active to the server. And this time, the server, instead of responding directly to me, the server is going to send it to everyone who's listening. Here are the users, including the person who just signed in. So as soon as you sign in, everyone gets a packet saying, not only are you and there's 5 other people who are signing in for, now there's another person whose name is Greg and he's active. Similarly, when I choose to sign out, I'm going to emit a sign out to the server, and the server is going to broadcast the new users to all the clients. And Greg is no longer signed in, so we want to see Greg disappear as soon as the sign out happens. Now, another method is called status. And a client, when you either bring focus to the window or when you blur the focus to the window, effectively leaving the tab or going to another app, we're going to send a status socket to the server. The server is going to update the status now and knows that I'm absent, no longer active, and it's going to rebroadcast the users and their presence to all the clients, saying, by the way, Greg before was absent or was active, now he's absent. And then finally, and this is really important, when a disconnect is issued, we're going to remove that user and send that back to all the clients, letting them know that either their browser crashed, they closed the app, they closed the tab, something happened. So that disconnect is going to adjust the list and rebroadcast everyone. So that's pretty much the kind of overflow or the flow of the events in this app. Any questions about this? I'm sure if you're a distributed computing engineer, you might have a lot of architecture problems with this, but I'm using the central server, yes, for storing presence, and maybe there's a way to do it with like broadcasting the network, but I chose to do it with a central server instead. Any questions? Yes?
So the disconnect, does that get caught like when the connection gets closed as opposed to an explicit event called disconnect? Like I'm just thinking
You don't actually get to implement connect or disconnect, or you don't get control over when that's sent. Connect is always sent when you open the browser. When connect and disconnect are also used if the server goes down. So if you have a bad internet connection, or the server is rebooted, or the server crashes, you'll get a disconnect immediately, and it will go into that self-healing mode that I talked about, trying to regain connection. And as soon as the server is available again, it will go through the connection process again. And we'll get to it, but that is the reason why with sign-in, I'm actually setting my status again, because if it goes down and it comes back up, everyone needs to send their status and their name again, because that socket server probably is forgotten, especially if it's using some memory storage, probably forgotten who was signed in, or something's changed since then. So we're just going to flush our data structure and repopulate with everyone's second information. So it's very self-healing in that sense. Any other questions about events? Awesome. So that is actually all of my slides. Yeah.
The disconnect can't get lost. So there are cases where you don't get this.
Yeah, no, I knew that there was probably someone who's a distributed engineer who had all sorts of problems with
To answer your question, there is a case where it can get lost, but in most cases it will be.
All right, so let's look at the app for a second, just for a second, so you can kind of see this all kind of working. So here I have 3 different, I'll be there. I have 3 different, let's say these are mobile phones, but they're really browsers. So I have 3 different browsers here. I'm going to sign into the first one. It's Greg. So Greg shows up, and since I have my tab active, it's all green. Now I'm going to click over to this one, and I just lost focus, so it's sent a broadcast to everyone. Okay, now Greg's no longer active. I'm going to come over here. I'm going to sign in with Sander. Now Sander is the active one, but Sander's been updated and on the list. Now I'm going to come over here. I'm going to go to Charles. I'll sign as Charles. Charles is the active one. As I go back and forth, you can see that that green dot is changing. So the architecture that I just described is really just making this thing hum. You see that you can sign in. If I sign out, disappear from the list, but I still maintain the list as before because when I signed out, I got the packet. I still got the packet because I'm still connected. I'm just not signed in. I didn't end the socket connection. I just end my kind of registration through sign in. Sign in again, come over here, Charles is going to crash. So it crashes, and as soon as it crashes, that disconnect happens. The disconnect now sends a emit to everyone where Charles is no longer there. And sign out and sign out. So that's the app in action. How many of you, once again, have used WebSockets before? And how many here are familiar with the Chrome developer tools? Yes, everyone, good. So Chrome developer tools are awesome for sockets. So check this out. You probably are familiar with the network tab. I'm gonna start up the app and go to network. And I don't know if you've noticed this before, but in the network tab, you have this little filter button that will let you filter what you're seeing. So I'm actually gonna go over to WS, which is my WebSockets, and I'll see this. I'm gonna refresh it again. And you'll see that first of all, it sends this connection to sock.js node, but eventually it falls onto this, and this is where I'm going to get all of my socket messaging. So check this out. I go to frames, and every message that's sent over the socket is going to come sequentially here. You can already see this 2, 3, 5. You've seen more. That's that heartbeat that I was telling you about. Information going back and forth. It's like literally like 1 kilobyte of information going over that socket just to make sure it's still alive and getting ready for that disconnect. So I'm going to go here, I'm going to sign in, and when I sign in, you'll see that I sent my name and my status, just like I said I was going to, and what I got back was a presence action, and I got the array, but the array with one user. And then you notice also that when I click on here and I click on the Chrome developer tools, apparently Chrome thinks that I've left focus. So you can see that the presence is being updated when I send the status. So this is really great. You can really see it's one connection. It's not like in the network tab when you're used to looking at HTTP, XML HTTP requests, you see them all as separate requests. It's really just one request, and there's messages being sent up or down. So the green is sent up to the server, the red is coming down from the server. And then of course when I sign out, I issue my sign out, I get presence back with no users, it clears it from my app. Yes?
So you said Greg when you sign in, is there like a including mapping of like a connection ID or something to put in Greg? Like how are you doing that as a feature?
I'll show you the code actually. So it's in the GitHub, which I just showed you, but we'll go take a look at the code in a second. I just wanted to actually look at the sockets in action and show you this, because this is like, it's really great. I mean, I love the Chrome developer tools, but you know, the idea of being able to see the sequence, to be able to actually inspect the data, to break out your objects. I'm now sending, I know that some people have moved towards abandoning their REST APIs altogether and sending all of their data over a WebSocket, which I think would be very cool. I'm not doing this yet in our open source project, but we use sockets for user presence, we use them for push notifications, we use them for chat, we use them for automatic updates to screen. So this is one thing that I really like. So we use REST in order to send an update to the server, but when that server saves the update, it broadcasts the update to all the people who are actively looking at that page. So everyone's page will automatically refresh. So we actually are using sockets to kind of trigger pages that weren't the person who actually submitted the information, but everyone who might be looking at that data, that they should get the newest data. And so this is how we do real-time updates, and it's actually working very, very well. Anytime someone goes to a page, they subscribe to that page. Anytime someone updates data on that page, the people who are subscribed get a push notification, time to refresh the page, and they actually request the information again through the REST. So it comes back in the format that each page wants, because sometimes data is represented in 6 or 7 different ways, depending on what page you're looking at. So sockets are super helpful for all sorts of different problems, and I'm using them on a daily basis. Any questions about any of those use patterns that I talked about? All right, let's look at the code then. Oh, we have it here. There we go. So this is a Node app. So for those of you who don't know Node, you have a package.json, and your package.json talks about all the libraries you need to run this in development and all the libraries that are required as dependencies of the app. You can see I'm using Socket.io, Socket.io client, and then a lot of other kind of helping libraries that help me do JavaScript transpilation and whatnot. In my source directory, I have a folder for the server, and I have a directory for the app. The app is going to be compiled using Webpack. So if I look at my server, this is what my server looks like. Very simple. So I'm going to load my Webpack config and the Webpack dev server. I load Socket.io and some other libraries. But I start up my socket, I create my I.O., and then I say when I get a connection, I'm going to actually call this other function that I defined elsewhere. So all of my application logic is going to live in this function, and we'll look at that page in a second. What I really wanted to do is just very quickly show you how easy it is to kind of define a connection and get started. I'm going to start my socket listening on port 3001, and then I'm going to start up a Webpack dev server, which is going to serve all of my dynamically compiled JavaScript, and that's going to listen at 3000. So my app, and we'll go back and look at the app in a second. You go to port 3000 to get the app. It goes back to port 3001 to get its socket request. That's all there is to the setup of the server. And then all of my logic happens here. So to answer the question that Ben had, I think, you said, how am I storing my users? Just in memory. I have a non-constant users array that I'm managing. But imagine that this is a call to Redis, or imagine it's a call to the file system, to a database. You implement it how you want. But I have an array that I'm going to allow to be mutated rather. And so presence gets the I.O., which is the connection to everyone, and the socket, which is the connection to the person logged in. As soon as I start the connection, I'm going to create a user variable that's scoped for this connection. And I'm going to emit to that person who just signed in the presence action. I'm going to send the users, which right now has no one in it. And now I'm going to set up some handlers. I'm going to say, when you sign in, I'm going to take the data, and if you issue the callback, I'll take the callback as well. I'm going to set the user equal to the name that was passed in, and I'm going to log to the console, Greg signed in. Then I'm going to take that user's array, and I'm going to add data to it, which remember had the name and the status. So now I have another user appended to the user's array, and now I'm going to emit that presence to everyone. So as soon as he signs in, Greg with the status of active is now sent to everyone else, and I'm going to call that callback that was sent in. If there was one, this is just kind of standard practice. If they didn't ask for a callback, then you don't need to worry about it. That gets passed in as kind of like a no-op function, like that is nothing. Same thing with sign out. The callback will come in. I'm going to say user, and the user is defined up here. I'm going to set when I signed in. Greg just signed out. I'm going to filter Greg out of the list, and now I have a new users variable. I'm going to nullify the user variable, and I'm going to emit that user to everyone else through the presence socket, and I'm going to call my callback. So very simple. I have a handler. I have an emitter. I mutate some variable. Right now it's in memory, but I could do it with database. Then when I get a disconnect message, this is going to happen when someone closes the tab, when they navigate away from the app, or the browser crashes. I'm going to, first of all, if I got that disconnect and they weren't logged in, no big deal, because I don't have any information to do anything with. However, if they are logged in, the user exists, then I'm going to say Greg disconnected, and I'm going to filter Greg out. I'm going to nullify the user that's in memory, and I'm going to emit the new users to everyone. So everyone gets a log that Greg's browser is closed or crashed. And then lastly, when the status comes in, I'm going to take the data, and I'm going to say Greg is now active, or Greg is now absent, and I'm going to map through all my users, and I'm going to update the status when I finally find the right user. I mean, it's very brittle because I'm using the name and not a user ID, et cetera, but you get the point. You're just basically mapping and mutating that one status, and now I'm going to send that back. So that's how I do my server-side implementation. All listeners and emitters, it's really just one big middleware function on the I.O. object, which we get out of box from Socket.io. Any questions about how that is implemented? Yeah.
So there's like a kind of pub sub API for categories of messages Are there implications of this for other backends that you don't happen to be using, particularly that's on the way or on top of WebSockets?
Yeah. So Socket.io, you can run it in the client, and I guess theoretically you could have some sort of backend that knows how to pretend like it's Socket.io running on Node. I don't know of any projects like that. I used to work on a pretty large like Ruby on Rails project, and we used Fay and Event Emitter, and maybe there's something better now. That was like maybe 2 or 3 years ago. So there's a lot of libraries that do WebSockets and will give you server bindings and client bindings. But really, if you're going to use Socket.io, you should just set up a little microservice that maybe connects to your Redis store, to your database, or some sort of shared store, even if you're using Ruby on Rails or Java or whatever for the rest of it. If you want to get this real-time layer, you can just have that as a microservice running in Node. And as you can see, it's super small. It's really trivial. Any other questions about that?
Just a comment I was just going to say, in my experience, the different WebSocket libraries are not very user-friendly. It's more like if you're using Socket.io, you need to use a local server, whatever Rails you're using, and use it on both sides.
Okay, and the nice thing to remember about Socket.io is it's not just WebSockets, because there's actually a native API for WebSockets, and if you're doing like greenfield browsers, you can just use WebSocket, or new WebSocket, which I think is part of the default browser. But the thing that Socket.io gives you that backwards compatibility. It gives you that heartbeat where it's going to know when something's going down. It's going to try to connect, and it's going to wait in the loop until it connects. Like you have to implement all that stuff by hand if you're using just the WebSocket layer. So Socket.io gives you kind of immediate proofing, so you can just deal with your app rather than have to worry about some of the improvements. Excellent. So that is the server, and oh yeah, my app is super simple. It's actually all in this JavaScript file. So once again, for those of you who aren't super React savvy, this is a component. It's a class. You have a render method. You have these lifecycle methods that happens when the component shows up on the screen, right before it leaves the screen. And then this is just the way I do my React, is I always name the standard methods with a lowercase, and all of my custom methods I always put an underscore, so I can tell the difference between something that belongs with React and something that I've done custom. All of my handlers I always call handle. And so lastly, because it's a class and because JavaScript is super persnickety about the this keyword, at the top of my components, I always bind this to the method so that we know that the this that we're going to be referring to in those methods is the this of this class. I don't know if any of you have struggled with that. It's a pain in the ass, but once you figure this out, you do it everywhere. So anyway, so I have a state, which lets me know if I'm currently joined, my name, which is what name I'm going to set in, and I have the users array as it's been delivered to me from the client. I have a method called blur focus, which is going to get called either when I blur or when I focus. I have how I'm going to handle the connect coming from the server. I have a method for how I'm going to handle presence. I have a method that's going to handle the sign in, the sign out, and then I have a method that's just going to handle me typing the name. When I mount the client, I'm going to initialize my connection to port 3001. Remember, I have my WebSocket running on 3001. And now I'm going to set up some handlers. When I connect, I'm going to call the handle connect method, which is implemented down here. When I get a presence message, I'm going to call the handle presence, which is further down here. I add a listener to the window, and when the window is blurred, I'm going to call handle blur focus. When I get the focus, I'm going to call blur focus again. And when this component unmounts itself, I'm going to unsubscribe the window from listening for those things. So basically here I've defined the entire behavior of my client based on any messages it might get from Socket.io. Everything else is just implementation details. So when I get the name, I'm going to set, when I start typing in my name, I'm going to set the value equal to what I'm typing in. When I connect, I'm going to set the, I'm going to look to see if I'm joined already, and if I already am joined, this is the situation where the browser, or rather the server crashed, and the server came up again, and it connected to me. Well, I'm already signed in, so I'm not going to sign in again. I'm just going to tell you that I'm already joined. So So I handle sign in, and that happens down here. It uses the name, it emits sign in to the server. It's going to give my name, it's going to look to see if I'm currently focused or not, maybe active or absent. And as a callback, once I'm signed in, I'm going to set the join value to true. And the join value to true tells my component that I'm currently joined or currently not joined. Maybe it could be called signed in or active, whatever you want to call it. But I'm using this join to know if I'm actually logged in or not. Same thing with sign out. When I sign out, I'm going to emit sign out to the server. And when the server verifies that I've been signed out, I'm going to set the state of join false. So my sign in button, sign out button will turn to sign in again. Lastly, with the blur focus, when I leave the tab or go back to it, it's going to find out what my name is. If I'm not signed in, don't care. If I am signed in, I'm going to emit my status back to the server and say, I was looking at it, but I'm no longer looking at it, so I'm absent now. Or I am looking at it now, so I'm active. And it's going to send that status back to the server. You remember the server is now going to update everyone else, letting them know that I'm now active. And then lastly, when that broadcast message comes with user presence, I'm going to get the users, I'm going to set the state to users. And up here, in my render method, this is potentially the least interesting part of the talk. This is just how it formats it all. So if you're joined, it shows that the sign-in text field is disabled, and if you're not joined, you can type it in. And when you change it, it calls the handle name. The button, if you're joined, it says sign out. If you're not, it says sign in. Then I just loop through my users, and there's a class that I put on here called user status. So it's either going to have the active class or the absent class, which is going to make it green and yellow. And I have the user's name. So that's the entire app. That's how I use the data that comes from the server and the data that I've put in locally to make it look the way it looks. I have my component mount and component will unmount, which kind of sets up and tears down the WebSocket connection. I have all of my handlers here, which are subscribed to and an on listener. You see a number of these handlers either set the local state or they emit a message back to the server. Once again, let's just take a peek at that server again, just so now that you've seen the client side, you can kind of look at this again. Just like we did on the client, we have emission, where we emit a message, and listener, where we listen for a message to come in. We do something, we initiate the callback that is defined on the client side. We say, go ahead and run that callback. Really simple API. There's so many things you can do with it, and the best part about it is it really doesn't tell you, it doesn't get in your way very much. It just gives you emit, it gives you on, and I didn't show you here, but there's one called join or leave, which is to join a room and leave a room. So you can say, I want to just subscribe to these types of messages, or I want to no longer subscribe to these types of messages. Here, this is more of a everyone gets everything. But if you wanted to scope it within a room, you can do that as well. So that's all I have prepared. I'm happy to talk about Socket.io or WebSockets in general, or if there's anything you'd like to see about Chrome dev tools or about anything that I've talked about. I'm happy to answer questions. Yes?
More of an observation was, we noticed that usually this is stateful. I wasn't kind of expecting of this. So in fact, we have the user at the top, and you keep that username, and then use it for all other callbacks throughout the whole thing. I don't know. It's just not how I was expecting it to work, but that's fantastic.
What I do in the Mohawk platform is we use a JSON web token. So when you sign in to the website, the actual HTML page, JavaScript takes your password and username, sends it to the server, compares the hash, creates a JSON web token with a little bit of lifetime, sends that JSON web token back, and that gets stored in the Redux store. We use Redux for our state management. And then as soon as you're logged in, it initiates connections to the socket using that JSON web token. At the very top of my connection method, I'm using the JSON web token to deserialize, figure out who the user is, figure out if it's still a valid web token, and then depending on what's asked, I check to make sure that user actually has access. So this is just a very simple method, but as I said, you can use JSON web tokens, you can use cookies, probably other security mechanisms you can use too.
Yeah, I think the point I was looking at more was, I was thinking of it as more like an event queue where you get messages and each message is kind of self-contained. But here you have more like a stateful handle.
Yeah.
A handle that knows about the socket, the user,
Yeah.
And it's keeping that state, so it's more like an active model.
Yeah, one thing that you might find interesting too is there's another, let's see, where am I going to find this? It's going to be in my Maha source code. This, it's going to be in, looks like, so, oh, no, I know. Okay, sorry about that. Source and the emitter. All right, so there is another library that Socket.io has, which is called the Socket.io emitter rather. So you can do all of your emitting through that stateful function, but not all of your app is actually going to be contained within that function. So if you're like all the way over here in like some distant corner of your app and you just got a REST request and you want to send something to your socket, like you're kind of shit out of luck because you have no context of that function where everything is defined. But if you're using the backend like Redis, there's no reason why you can't throw something into Redis and it goes back out through the socket. So the emitter actually works that same way. So if you're subscribed to the same Redis server, the same Redis database, both the emitter and Socket.io on the server are listening to like the same key value store. So you can actually in your, I think it happens, yeah. So right here, I have the emitter and I'm in like some crazy like corner of my application, and I'm calling asynchronously socket in which channel I want to emit the message in. I'm just emitting a generic message. I use the word message in my app, and I'm setting the target, the action, and the data. So there is a way that you can actually emit from anywhere in your app, but for simple purposes and for like simple chat apps, you might actually just emit everything within that stateful function. But it can go both ways.
And so I do have a lot of jobs that are run that are really, really long running, and I make it so that you use Socket.io, so that as the job's running, it just basically is like sitting back almost like a terminal screen. So you're like, hey, job's running, oh, I did this, and just like, it's a way of sort of like doing long polling the HTTP just can't support. So it's a way of sort of keep sending the statuses to finishes, and then great, done. And so,
yeah, that's a really progress updating.
Progress updating.
Great.
It does really work on HTTPs.
So in the Maha,
sort of, I don't know, doing something status.
in the Maha platform, we use this for assets. So we have at the core property extension, people take a picture of receipts, and those receipts get uploaded to a server, and then they have to classify the receipts so they can go through finance, and at the end of the day, they can just do a huge database query and figure out how much money was spent on this project and all that stuff that went through the Visa card, etc. But what happens with our file uploader is you upload your file, it sends several chunks. We use resumable.js to send many chunks to the server, and then when the last chunk is received, we open up a WebSocket connection with the client. The client gets a little spinner, but it shows a preview of the image that was uploaded. Meanwhile, on the server, it adds all the chunks together to recreate the asset. It takes a snapshot of it if it's a JPEG or if it's a PDF or a Word document or Excel. It takes a snapshot of it, and then it sends the fully kind of rendered serialized JSON with the link to the snapshot as well as the link to the asset if you want to download it. And now it's there on the page with like a compressed version of it. But all that happens in a worker, and we use that socket to keep updating the client with what's happening if it's done.
Navigate away, you can go somewhere else and something else.
That's right, because
it's done in 5 minutes later.
You'll see this in Workday. If you guys work at Cornell, you also see it at, in the Google, the API console. A lot of times you request to do things, and then you'll browse away, and then a notification pops up with something done. You click on it and take you back there. This is why I'm saying a lot of people are leaving REST and using web services, because it's completely asynchronous. So you start a process, you go and do something else. When it's done, you get notified with a notification to bring you right back to where you started. So it really allows for that kind of multiple layered workflow.
So a lot of people go in this way to this office instead of REST, but I can imagine one benefit if you have close to
Right.
What are the other applications of using this office?
Well, it's faster, right? So you don't have to do the setup and tear down.
There's a bunch of web framework, JavaScript frameworks like Happy. There's a slew of JavaScript frameworks as well. But Happy, I think, uses just sockets.
Sales does too.
Sales, I can't remember ridiculous names, but a lot of them are based strictly on WebSockets, and that is HTTP all. Express, which is the most popular, does still use HTTPS. I think it allows you to do both.
That callback piece is really helpful because if you use a callback, you can make a request and say, I want you to call me back with the data when you're ready. So you send your request for some sort of process to happen. You can just wait and you get your callback, and your callback has the same thing that you would have gotten for XML, HTTP, like whatever the response is, the data. Yes?
Have you solved the scale of the problem of sticky section? That's ultimately the problem.
Yeah, so we use EC2 and HA proxy, and HA proxy has a way to do sticky sessions where it assigns a cookie to the connection and sends it over to the socket.
So about a million people logging in right now. We all get assigned to them also, because the next service.
It uses
So all of a sudden, all of my, multiple connections are sticky to the one server.
I don't know exactly what the resource usage is. I haven't, I mean, I have 250 users at any given time, probably have like maybe 10 or 15 markets, so I'm not going to Google or Facebook by any means right now. So I haven't dealt with the edge cases scalability. But it's pretty lightweight from what I've seen. It's very fast, very lightweight, and I can imagine it can handle a lot of connections. We do have 2 app servers, and it is random, like there's the assignment. So I don't think we ever have a situation that's like, oh, look at these people. Yes. Oh, the amount of data you can send over a socket? It's a really good question. I mean, I dealt with like cookie overflows by putting too much information in a cookie. So clearly there's probably some sort of like limit. I don't know. I have to look it up, but I can imagine that there might be. Although, I researched it recently, how long of a URL you can have. Maybe you know this, being a security researcher. You can have like thousands of characters in a URL. You can have like a huge data set stored in a URL. And it doesn't clip it off out of it. You just probably want to be smart. If you're sending that much information, you might want to chunk it, or maybe you're doing the wrong thing. Maybe it's a file download you're trying to do. Yes, I have seen binary data sent through Socket.io. I'm just sending JSON right now. I've been thinking a lot about, you were talking about security over the line, and you can use HTTPS, but there's also something to be said for somehow zipping or obscuring your data and encrypting it before you send it even over an encrypted line, and then you have on the client side somewhere to be decrypted back in the JSON. So I actually have, once you know how this stuff works, you can peek around on everyone's website. And, I use the React debugging console to look at Facebook sometimes, but sometimes we'll look at the network and see if they have a WebSocket. And a lot of people aren't sending JSON; they're sending some crazy hash. And I imagine what they're doing is they're encrypting the data, even though they're over an HTTPS connection, and they're serializing and deserializing it at each other, which probably wouldn't be hard. Probably just one function on each side. Have you done any?
I think you definitely want to use the channel if you can. But yeah, you can. I'm testing it out right now. If I use Socket.io, which is your WebSocket, so they're doing it where they're doing it's like the client sends 4 messages, so it sends the information in the first WebSocket message, then a begin, then the data request, and then an end, and then it gets back a variable back, and those are chunked.
Right.
So it's
So that actually would probably be a solution to what Sammy was talking about. So there's some protocol that they've implemented on top of WebSockets where they can send an arbitrary amount of data, but something that scales to be very large, but they'll chunk it up and they have a way of doing it again. Yeah, that's really smart.
Another fun thing here is called pieces of binary JSON.
Right. And so if you're libraries that are available that will return your JSON and JSON.
Actually, I really want to get back.
We used it for sending images to the website.
I really wanted to ask you this question. So, say you do have some sort of architectural pre-shared keys. Where do you store that on the client side so that it's not hackable by someone who knows how to dig into the console? If you had some sort of
so web client?
Yeah.
Nothing should be classified as client. It's safe.
Yeah,
Just
right.
talk to it.
Yeah, I mean that's right. You just use the secure channel, the TLS, the web, WSS, right? The secure web socket. And you just use either you do the session information in that first request, or you do it with your cookie and your GitHub.
Right. Going back to my
Like URL is always correct, because you always need whether key
Yeah.
yeah.
You don't. So you got it.
You should have to the client that you want to use.
So the way that I handle this right now is I have an SSL certificate sitting on a load balancer, and HA proxy is doing HTTPS. And so when everything hits here, which are only accessible through my load balancer, you can't access them through any other channel, then it just hits it over port 80. So we're using our security at the load balancer right now. And we're not encrypting or decrypting anything in any other way other than just a direct HTTP. So, yeah. Tweet your friends. Yeah.
So getting back to interest, so technology is say we use a base is it more efficient to use basics to work on it versus looking at the default?
Yeah, I mean maybe. I think it depends on your application. I mean, like you saw there, I was sending very small amounts of data back and forth, and quite often, if you're using chat app, you're really sending maybe 5 more characters, maybe less. You're sending a little message back and forth. You're not sending any files, so it's probably overkill to have to do all that encryption, or even compressing. But the whole point of using MSAC is over rest. I mean, not all of them. One of the reasons you might use it is for speed, because you can speed things up, or you're just on a very unreliable network. And your use cases, like when people are out in the field, you may be connected, may not really have a really slow connection. So using some sort of primary zipping is probably smart for And then if you think about it, if you're not using BSON, which I imagine BSON has some sort of direct, BSON to a JavaScript object. But think about it, you're going to have to go from basic keyboard to string, and then you're going to parse that string. So there's the JSON on that parse you have to do. So it will add overhead also depending on the size of the data. So, there's lots of different solutions. So 1, you can zip it. 2, you can chunk it. 3, you can just make sure that your request never send more than small bits of data. So, the way that I do presence on the Mana platform, I actually just set user IDs. I don't even send all the information. I set a user ID and I maintain an array of user IDs. And whenever I go to show a user avatar, I use the context within React to jump up to that presence and I say, is my user ID in there? If so, put a green dot. If not, don't. So you don't even need to send a lot over the wire if you're doing user presence. 100 integers is something like that to show off people. 1,000 integers you can probably even swing with that into a file. Maybe more than that you want to show. Any other questions? All right, thank you.
I don't really think it's really to say, but thank you everyone. Thank you to our presenters tonight, and have a good evening.
How about next month? We want to see what next month and speakers.
Send up Trello board, Trello up there.
Yeah, do you want to come in? Like, we're gonna recruit you.
Are you guys hiring?
Well, I'm hiring. There's a Trello board, there's a Slack board, there's meet presenters for September, October. Holler at somebody about something. All right. Have a good night.
Thank you, Ben.